Welcome back, everyone. Today, we're going to be proving this trigonometric identity here. So before we get into it, let's talk strategy for a question like this in general. I noticed that on the left side, we have just one singular trig ratio of secant theta. And then on the right side, we have a subtraction problem with some fractions. And so the side I really want to simplify is the subtraction side. I want to get it into be one singular trig ratio, because once we do, we'll be able to see that it is indeed secant theta. So that's our strategy here. Next, I'm going to rewrite my question. Left side is secant theta, and my right side, which is mostly what we'll be working on today, is sine 2 theta over sine theta minus cos 2 theta over cos theta. And also, I want you guys to recall some of the double angle identities, because we're going to need to use both those identities in order to simplify this further. So recall that sine 2 theta is equal to 2 sine theta cos theta, and also that cos 2 theta is equal to cos squared theta minus sine squared theta, like that. So in my next line, I'm going to replace sine 2 theta with 2 sine theta cos theta. And I'm going to replace cos 2 theta with cos squared theta minus sine squared theta. Okay. The next thing I want to tackle is the fact that we don't have the same denominator. So I'm going to multiply numerator and denominator of the first fraction with cos theta, and then numerator and denominator of the second fraction with sine theta. And if I do that, let's see what we get here. We're going to get one fraction with sine theta cos theta as our denominator. And then in the numerator, we're going to get 2 sine theta cos squared theta, since we're multiplying cos theta by cos theta. And then minus, in brackets, sine theta times cos squared theta minus sine squared theta. Okay, and now let's see if we can simplify this more. I'm going to see if we can expand this and then potentially common factor something out to cancel with the bottom, stuff like that, because we still want this to be even simpler. So we get 2 sine theta cos squared theta, and then minus sine theta cos squared theta when we do this multiplication. And then when we do this multiplication, we get minus a negative gives us plus, so plus sine cubed theta, and that's all over sine theta cos theta. Okay, so now we have 2 sine theta cos squared theta minus 1 sine theta cos squared theta. So we can simplify that to just get 1 sine theta cos squared theta, and then plus sine cubed theta over sine theta cos theta. And then from there, I'm going to factor out a sine theta. So sine theta times cos squared theta plus sine squared theta all over sine theta cos theta. I'm going to then cancel these out, and also recall that cos squared theta plus sine squared theta is 1. So this simplifies to 1 over cos theta. And by definition, 1 over cos theta is equal to secant theta. And sure enough, if we zoom back out, that was what the left side was. And so we have done the problem correctly. If we get a different ratio other than secant theta, then we'd have to check our work and go back, because that would mean either we've done it incorrectly or the question was based on a false premise. All right, well, feel free to leave any questions you might have in the comment section, and we'll see you for the next one.